Hello everybody, welcome to 33 JS concepts every developer should know. Today we have the number 9, message queue and event loop. So first, before we can start learning what this is, we need to understand why JavaScript is awesome and what is blocking and non-blocking. JavaScript is non-blocking. For example, I think Python is a blocking language. In the case of JavaScript, it is not, and I'm going to show you why. So for example, imagine that JavaScript was a blocking language right now, okay? What would happen, for example, would be that you have a website, and let's say that on your website there is an input, and the user is typing on the input his name, for example. Very, very happily, there is an input, and the input works. Now, if JavaScript was blocking, what would happen is that if the user, for example, is typing their name, no problem. If JavaScript was blocking, the user wouldn't be able to keep typing because JavaScript would be busy handling the fetching to the API. That will be blocking. That will mean that JavaScript can only do one thing at once, and that includes user input, that includes events, that includes fetching, that includes everything. So imagine that JavaScript was blocking. It would be incredibly complicated to do anything on the website. Now, JavaScript doesn't have many blocking things anymore, but I can show you something like this. Even they say that here. Alert, for example. Alert is a blocking function. It blocks JavaScript, literally. If I do alert, hello, for example, that is going to stay here. And as you can see, I cannot touch this text. I cannot do anything. Literally, nothing at all. Nothing. Look at this. Look at this. Now, what happens if I do something like alert, hello, right? And immediately after, I do console log hi. As you can see, JavaScript is blocked right now. Console log hasn't been executed. This is because alert, for example, is a blocking function, all right? So imagine that JavaScript was like this. Imagine that everything was blocking. Imagine that fetching something for an API was blocking the input of the user, or doing a console log would block a request from the fetch. That's crazy, and that wouldn't work. This is why JavaScript is nice, because everything is done in parallel. Everything is done via events or callbacks. That's why you can maybe take a button, for example, and you can say add event listener click. JavaScript is going to wait for that click to happen. That's nice. Now that we know what non-blocking is, we need to look into where does JavaScript put all the other things that happen in parallel. Where do they go? For example, if I set a timeout and my timeout will just say, I don't know, console log, right? And it will do it in 5 seconds. Where does that go? Who's keeping track of that? Where is the console log in 5 seconds happening? Where is it going? This is what we're going to talk about today. That is the event loop with the example of set timeout. Also, we're going to understand why some things, like for example, look at this, set timeout. Let's say set timeout console log hi. It's an example. Let's wait 0 seconds, right? And then let's do console log bye, right? We need to understand why bye happens first and then hi, okay? And that's what I'm going to explain to you after this long ass intro. Let's look at my beautiful diagram that I just made here. Now, I know you remember about the call stack, all right? The call stack is what JavaScript does to keep track of the things that it has to do, okay? So if I just do these two things, if I write console log hi and then console log bye, what's gonna happen is the JavaScript is gonna do console log hi, he's going to finish it, push, and then console log bye, and he's going to finish it. That will be it, right? That's why this console log hi and bye will be in order. First one, finish it, the next one, bye. Now, what happens here when I put a console log hi, but that is inside the timeout, is that what JavaScript is going to do is that it's going to take this beautiful timeout and it's going to put it somewhere else. And in this case, we can call this box the web APIs. Now, web APIs are many functions that JavaScript doesn't have by default on the core, but are implementations of the browser. Let me give you an example. You know local storage? Local storage is to save things on the browser, because local storage is a functionality defined by the browsers. This set timeout and all these things, this is implemented by the browser as well. Okay? Now what's going to happen here is that JavaScript is going to take this set timeout. JavaScript is going to look into how long should I wait for my message, in this case 0, right? And it's going to put that into a queue. Okay? Now the queue is a message queue, which is message from the web API or event boxes, whatever you want to call it. All right? And now the rule is that JavaScript will only take things from the message queue if there is nothing on the stack. I know this sounds complicated, but bear with me. So what we do here, let's do it again. Let's go back out, capush and set timeout. All right? So what we do is that we add, imagine that this is inside of this, okay? So we take this and we add this to the stack. Boom. JavaScript sees this thing, which is set timeout, which is something that should be in parallel. So he's going to take this beautiful code and he's going to put it here on the web API box. Which this is the browser. That is something that the browser has to handle. All right? And then he's going to execute by. When he executes by, he's going to pop it off the stack and it's finished like this. It will say bye. Then the web API, the browser implementation of the web API, is going to look into the second argument of set timeout. And that will be how much time to wait until we execute that function. In this case, we want to wait 0 seconds. Now, I have a surprise for you. The second argument of the set timeout is not actually how much time to wait. Is minimum how much time to wait. It doesn't guarantee you that it's going to be exactly at 0 seconds. It guarantees you that it's going to wait minimum 0 seconds to fire the statement, all right? So what happens here is that web API says, all right, we're going to wait for 0 seconds. Boom, we waited for 0 seconds. And that function, whatever that is, that goes to the message queue. Then, again, remember this rule. If there is nothing on the stack, JavaScript is going to look into the queue and it's going to see. It's going to be like, yo, is there anything on the message queue? Yes, there is. What is it? It's high. Then it's going to look into high and it's going to pop it off the stack. And that's why we get by and high later. Okay? Remember, very, very important. Now you can ask me, okay, Nicolas, what about fetch, for example? It will be the same thing. If you fetch something, let's make fetch as a circle, beautiful circle. If you fetch something here, that will go to the web API. The web API is going to call whatever website, and then when it comes back, that function, the callback, whatever that is going to go to the queue. And then when JavaScript feels like he's ready, he's going to call that message from the queue and execute the function again. All right? This is not a super important thing to know when you work with JavaScript, but it's very useful to understand why we have so many things like callbacks or events or, yeah, that's it, callbacks or events in JavaScript. Because it's non-blocking language, we need to find a place to put all these set timeout situations. That's it. Thank you for watching. I hope you understood this. I hope the explanation was good enough. If you don't, feel free to Google, but it's not a big deal to understand. Just that's it. Thank you for watching and see you on the next video. Bye-bye.